We'll be going over the Unit 3C test review, and this first video will be on 1 through 19, the multiple choice questions. Number 1 is asked, in here you're asked, what is the vertex of the graph to the right? The vertex is your bottommost or topmost point on your parabola. So if we go left 1, 2, 3, we then go down 1, 2, 3, 4. So our vertex is -3, -4. And -3, -4, you've got to choose from C or D, but also determine whether it has a maximum or minimum. Remember that a max is when you have the highest point, a min is when you have the lowest. So this is definitely going to be C. Number 2, how is the graph of -2x squared minus 6 different from the graph of -2x squared? Recall that the constant term at the back of your function is your vertical shift. We should recognize that our vertex is 0, -6, and to graph 0, -6, we would not go left or right, but go down 6. So if you aren't sure about that, then we can first graph. It says, how is this different from this? So that means you're starting with -2x squared. So I would go to y equals and type in -2x squared. And then below that, type in -2x squared minus 6 to see how it's different. So here's -2x squared. And here is -2x squared subtract 6. So you can see that it shifted vertically down 6. So it shifted 6 units down. Number 3, what is the graph of the function that is reflected over the x-axis? That means it opens down. Shifted left 2 and up 3 from the parent function. So recall that your parent function starts at 0, 0 as for the vertex. So if I go from 0, 0, left 2, and then up 3, left 2, up 3 is going to put a vertex right here, and it's going to open down. So you should be looking for the parabola where you go left 2, and then up 3. And then it is vertically reflected over the x-axis, opening down. So this was C. So 4, find the vertex. So a couple different things you can do. You can recognize that because this is in standard form, you can use the opposite of b over 2a to get started on your vertex. So if my b value is 14 and my a value is an understood 1, the opposite of my b value would be -14 over 2 times my a value, which is 1. -14 over 2 is -7. So that means my vertex starts with the order pair -7. So that means it's definitely not B or C. And recall after that, you can go to y equals, type in your function x squared plus 14x plus 36. Look at your table for the x value of -7. And then look beside it to see your y. So it's going to be -7, -13. Another thing you could do is simply graph it, but of course notice here we don't see the minimum point, but at least you know it's in quadrant 3. So quadrant 1, quadrant 2, quadrant 3, and in quadrant 3 both coordinates are negative, and you'd have to go 1, 2, 3, 4, 5, 6, 7 to get to the middle. Think about your axis of symmetry going down here. So it would make the most sense that it was -7, -13 instead of -13, -7. All right. Moving on. Let's see. To number 5. Number 5 is an application problem. So it says Linda shoots an arrow at a target in an archery competition. The arc of the arrow can be modeled by this quadratic function where x is the horizontal distance. So I'm going to do distance in meters because it's always important to interpret your units. And y is the height in meters of the arrow. So how far from Linda does the arrow hit the ground? So imagine if Linda's standing here, she shoots the arrow from 4 feet up in the air. Oops, 4 right here. So if she's standing here and she's getting ready to shoot this arrow, it's going up and coming down and hitting the ground. So we are looking for the 0 on the right. So recall to do that, we go to y equals, type in our function, always make sure you typed it in right. Okay, and if we hit graph, there's her 4 feet. It goes slightly up and then comes back down pretty quickly. If I want to find when it hits the ground, I want to find the intersection with the x-axis, which is at y equals 0. So go to y2, put in 0, move to the left and make it bold. Hit graph, and there's my y equals 0. We're trying to find the point of intersection of our x-axis with our parabola. So we're going to find the intersection by pressing second, trace, 5. We have to arrow over to the right, so it gives us this intersection point, and press enter 3 times. And we get 3.55, and it does say round to the nearest tenth. Keep that in mind. While the answer does show 3.55, if you choose D, it will not be correct. And the reason is, if it's 3.55 and we're rounding to the tenth place, which is one number after the decimal, if the number that precedes that place is 1 or 5 or higher, then this gets rounded up. So we need to choose 3.6 meters. So please read the problem carefully. Next, it asks for the axis of symmetry. Your job is to remember that the axis of symmetry goes through the vertex. So if this is our vertex, it'll go through it, and it'll always be x equals the x value from your vertex. So if we can identify your vertex by doing opposite keep or switch keep, our vertex is -4, -3. So it's going to be x equals -4. Right off the bat. Don't even choose the one with y equals. Now, if you really don't remember that, all you got to do is type it in the calculator, just as you see it. I'm going to go down here and clear this out. Then when I graph this, I should be able to look at it and see what is the x value that would cut it in half. So if I just kind of sketch on there, right there is where it would show us the x value. So that's 1, 2, 3, 4 to the left of the origin, which means it's at -4. And it goes to the x-axis, so it's x equals. So x equals -4. Next, for number 7, what is true about the graph of the function to the right? So what are things we know? We know the vertex is over here in quadrant 2 because that's where our x's are negative and our y's are positive. Here's my vertex. So it says, let's use process of elimination. The coordinates of the vertex are -2, 0. That is not correct because -2, 0 is right there. So that's not right. The axis of symmetry is x equals -2. That, however, is correct. Now, if I were to question this, -2x squared plus 2, then certainly I would simply type it in, look at the graph, and go, does that match? And that definitely does not match. And it says the x-axis of symmetry is the y-axis. That only occurs when the y-axis here, when the x-coordinate is 0 of your vertex. In other words, 0 something is my vertex. So not going to happen. So it's B. Next, what is the vertex of the function? Opposite keep. So 1, 4, switch keep. That's D. We could certainly also type that in our calculator and look for the minimum point as well since it opens up. Next, which equation defines the image of y equals x squared under a translation 3 units right? So from the origin, if I go 3 to the right, so think about this. If I go 3 to the right, then my x-coordinate is 3. We don't know what the y-coordinate is, but if all it says is I go 3 units right, then it's 3, 0, which means my k value is 0 and my h is 3. When I plug it into Vertex Form, this is where I would plug in my 3. So I'm looking for x minus 3 in parentheses. So it's A. But of course, I could compare it by typing in x squared and y1, type in my answer choice, graph it, so here's x squared, and see if this graph, next equation goes 3 units to the right, and it does. So I went right 3, so I know A is correct. Next, for number 10, which equation defines the image of y equals x squared under a reflection over the x-axis, so we've got a negative a, and a vertical compression by a factor of a half. So that means I should see a 1/2 for my a. So my a is negative 1/2. And I simply plug that in front of my x squared, because it's normally y equals ax squared plus bx plus c. So my a goes in front of my x squared. So we should be choosing D. Which of these parabolas is the skinniest? Remember, it is skinniest when our a value is greater than 1. The higher the value, or I should say the absolute value, meaning doesn't matter if it's positive or negative. But certainly we could type these in. I'll go ahead and tell you, fractions make it fatter, so it's not going to be that. This is our parent function, so we should be comparing which one is skinniest. But I'm going to keep my x squared in there as a comparison. I'll make it where that's not bold anymore. All right, so if I type in 2x squared and negative 5x squared, I'm trying to find the skinniest or the most narrow graph. Here's x squared. 2x squared, definitely skinnier. Ooh, negative 5x squared, definitely the skinniest. So I'm going to be choosing D. So it doesn't matter if it's positive or negative. If I take the absolute value of that, it's positive 5. So that's what I'm looking at, of a value of 5 compared to an a value of 2. Remember, we said the larger the a value gets, the more narrow the graph will become. Next, what is the function for the graph to the right? My recommendation would be to look for the vertex. Our vertex is at negative 3, negative 4. And I can tell we go out 1, up 2 on both sides. So my a value is a positive 2. So I'm plugging this into vertex form, a times the quantity x minus h squared plus k. My a value is going to be 2. It's going to be x minus my h value. Well, when I do minus a negative 3, it's going to turn it into positive. And then I keep my k value. So I should be looking for 2 times the quantity x plus 3 squared, subtract 4, which is D. But, of course, we could always just use our calculator as well. So I'm not going to type all of them in, but because I know that this is the answer, type that in my calculator, look at the graph, and that definitely matches the one on paper. In fact, we can do second trace min just to verify that our minimum is indeed at negative 3, negative 4. And it is negative 3, negative 4. So that is the correct graph. So that's 12. Last page here, or last part. I know you all have 2 pages to a page, basically. So let's go ahead and work on 13. Which equation defines the image of y equals x squared under reflection over the x-axis, meaning my a value is negative. That means it's not D. With a shift to the left 2. So think about your vertex. If I go left 2, down 5, that means my vertex is left 2, down 5, negative 2, negative 5. Remember, opposite keep when we plug it in. So h and k. So I should be looking for plus 2 with a minus 5. Negative and a plus 2 with a minus 5. That looks correct. So let's see. If I compare that to x squared and type in my answer choice here, I'm looking to see if it makes it flip over and then go left 2, down 5. Here's my parent function. Left 2, down 5. Yep, left 2, down 5, and it opens down. So A is correct. Which one is the widest? Remember, widest or fattest happens when we have an A value that is a fraction between 0 and 1. So here that's 1, so that can't be correct. That's a negative 2, which is not between 0 and 1. Not correct. So we've got to determine which of these is widest. So go to your calculator, type in 1/2 x squared, and then 1/6 x squared. Graph it and see which one is wider. Here's 1/2 x squared. Oh, 1/6 is definitely wider. Next, which equation transforms the parent function by shifting it 2 units right, 2 right, and up 8? So that means my vertex is at 2, 8. It vertically compresses by a factor of 1/3, and it reflects it over the x-axis, which means my a value is negative 1/3. So I'm looking for negative 1/3 in the front. I've got it there. I've got it there. It can't be these two. And I have to remember opposite keep. So I'm looking for negative 2, positive 8. Negative 2, positive 8. It's B. Here my vertex would be negative 2, negative 8. So it might help for you to just take your answer choices and write out your vertex and see which one matches. So it's definitely B. Next, a baseball player hits a ball with an upward velocity of 60 feet per second. Its height in feet after t seconds is given by this function. What is the maximum height? So that means we're looking for a ball that's being thrown starting at 6 feet, because that's our constant. It goes up and comes back down. What is the maximum height that it reaches? And we have to round to the nearest tenth. When I look at my answer choices, this is the 100th place, so I know that cannot be it. So I'm going to go ahead and y equals, type in my function. Graph it. Oh, he's throwing it really, oh, he hits the ball, so it goes way high up in the air. I'm trying to find the maximum, so I'm going to go to second graph, and I'm looking for my values in quadrant 1. Well, it appears to go up to at least 62, so I'm just going to go in here to my window and to my y max and set it at maybe 80, because I know that's higher than 62. Perfect. So I want to find this maximum point, so I'm going to do second trace max, arrow up to the top, press enter on the left side of my vertex, move my cursor to the right, press enter to mark my right bound. It says guess. Yes, I want it to guess. So now I can see that at about 8.9 seconds, it reaches a height of 62.25. That's an exact value, and it is on here. But if you don't pay attention to where it says round to the nearest tenth, you're going to miss it, because this 5 makes this 2 here round up to 3. So I'm looking for 62.3 feet. So we should choose C. Next, for 17, a baseball player hits a ball with an initial upward velocity of 60 feet per second. Its height h in feet after t seconds is given by this function. What is the initial height? Your job is to remember that your initial height is your constant term. So it's 6 feet. This is initial velocity. Your B value is initial velocity. Your C value is the initial height, always, for a projectile motion problem. Something going up and then back down. Next, for 18, a baseball player hit a ball with an upward velocity of 60 feet per second. Its height in feet, blah, blah, blah. When does the ball hit the ground? So if we want to know when it hits the ground, this is what I'm looking for. So just like we did earlier, we're going to take our function, put in 0 and y2, move over to the left to make it bold, hit graph, and find the intersection of our x-axis with our parabola when it comes down and hits the ground. To do that, we press second trace 5, since we're finding an intersection. I move it to the right side of the vertex and press enter, enter, enter. And we get 3.8. And it says round to the nearest tenth, so make sure you're doing that carefully. Do not make the mistake of saying 7 rounds the 4 to a 5 and the 5 to an 8. It doesn't work that way. You only look at one number to the right of the 8. If it is less than 5, we do not round the 8 up. It stays 3.8. Lastly, for 19, the graph of a quadratic function has this standard form, and it passes through these points. My recommendation would be to take these order pairs and write them in a table, a vertical table, and recognize that you're trying to find what is the value of the function when the x value is negative 3. That's what I'm trying to find. But if I have order pairs and I don't have a function, I can't look at a table without a function. So I'm going to clear these out. Go up. What am I doing? Trying to get off work on a Friday. I'm tired. So everybody go to stat, enter, and type in your x's. So notice I went to stat, and I pressed the enter button to edit my list. Now I'm going to enter my x's in my list 1. So 0, enter, 3, enter, 6, enter, -8, enter, 10, enter, 34, enter. Stat, arrow right to calc. We want the quadratic regression, so I'm just going to press the 5 button. Yours probably has the thing where it goes to store reg EQ. I'm using an older calculator that's not updated. So either way, you go to store reg EQ, press vars, right to y vars, press enter for function and enter for y1. So yours should say y1 beside the store reg EQ. I press enter, there's my function. When I go to y equals, it's already there. I look at my table, and I'm trying to find my y value when x is -3. So I'm going to arrow up on my table, and beside the -3 is a -20, which is C. And that concludes the multiple choice section of your test.